Welcome back to the deep dive. Today we're getting into something really critical for any major facility. We're talking about how to stop a tiny leak before it becomes a full-blown disaster.
Yeah, and we're using the NTI E-TLD-P50 tape-style detector as our source for this one.
So our mission today is to look at this thing. It's got let's say, a significant price tag, about $1,400 for 50 feet of it.
Exactly. And you have to ask yourself, why so much for what is essentially a water detector? So we're going to get past the price and really dissect the engineering that justifies it.
Okay, let's unpack that. When you're talking about continuous coverage
Mhm.
over 50 feet, what's the actual mechanism here? How does it work?
Well, at its core, it's about the anatomy of the sensor itself.
Yeah.
It's this self-adhesive tape, and inside it, you have these specialized copper fiber electrodes.
Yeah.
They run the whole length, and they're protected by this, durable netting. The whole thing is designed specifically to detect conductive liquids.
Ah, conductive liquid. So that's an important distinction, isn't it?
It is. It means water or water-based solutions will complete the circuit between those fibers. But say an oil leak, it wouldn't trigger it.
Right. So you're not getting false alarms. You're focusing resources on the right kind of threat.
Precisely. And the sensitivity is where it gets kind of mind-blowing.
This is the part I found really interesting.
Yeah. The spec sheet says it can sense a minimum puddle of only 0.125 inches.
Which is what, about 3 millimeters?
3 millimeters. I mean, think about that. That is smaller than the head of a thumbtack. You are catching a problem at the droplet stage, not the puddle stage.
That's incredible. But with that kind of sensitivity, you have to talk about reliability. I mean, what's the point if you don't know the system itself is working?
And that's maybe the most critical feature. The system has a continuous tape integrity self-check.
A self-check. So what is that doing exactly?
It's constantly making sure the tape hasn't been cut or damaged or even just unplugged before a leak ever happens. It's like it's taking its own pulse every few seconds.
But wait a minute. If it's always checking itself, doesn't that mean it's constantly drawing a lot of power? How does that work for long-term monitoring?
You'd think so, but that's where the smart design comes in. The power consumption is tiny. We're talking just 60 milliamps at 12 volts.
Wow. Yeah.
It's designed to just run quietly in the background for years. And it connects to these dedicated external units, the E2D, 5D, or 16D models.
And those are more than just power supplies, I assume.
Oh, yeah. They're the brains. They take that simple alert, that I'm wet signal, and integrate it into your whole building management system. Actionable alerts.
And the physical build supports that, right? I saw it mentioned a weather-resistant enclosure and underpipe mounting.
Mm-hmm. That means you can stick this tape in a really hostile environment, like a humid server room floor or a freezing cold pipe chase where condensation is a real risk.
So it's not going to be fooled by the environment itself.
Exactly. And when you connect this to the bigger picture, you see how it all fits. The scalability is key.
They come in different lengths, right? 10, 25, 50, even 100 feet.
Right. So you can cover exactly the area you need to protect. And when you think about the potential cost of something like a data center going down,
Millions. It
Yeah.
could be millions of dollars in downtime.
so suddenly that $1,400 tape that's constantly scanning for a 3 millimeter leak starts to look like the cheapest insurance policy you could ever buy.
So when we put it all together,
Mm-hmm.
what this really represents is a super specialized, dedicated tool for managing risk. It's not just detecting a leak, it's verifying its own ability to do so constantly.
It is. And that leaves you with a really important question to think about. The sheer engineering effort here. The copper fibers, the constant self-checking, all to spot a tiny puddle. Given how simple the threat is, just a leak, what kind of unseen critical vulnerabilities are being protected by this level of certainty? And maybe more importantly, what happens when that certainty isn't there? Something for you to mull over until our next deep dive?